You ever notice that little padlock icon that pops up in your browser's address bar? Yeah, we see it all the time, but what's it really doing? Well, that little lock is the final signal of a secret, super fast negotiation that happens every time you visit a secure site. All right, let's pull back the curtain and take a look at the web's secret handshake.
I want you to imagine for a second writing your credit card number on the back of a postcard and dropping it in the mail. I mean, it sounds crazy, right? The mail carrier could read it, the person sorting the mail could read it, anyone could. Well, believe it or not, for a long time, that is exactly how the internet worked.
So, to really get why the solution is so clever, we've got to go back and look at the original problem. You see, the early web was built on this amazing idea of trust and openness. But it turns out that was also its single biggest weakness. The internet's original language, its OG protocol, is this thing called HTTP, Hypertext Transfer Protocol. It's fantastic at fetching web pages, but it has one huge, glaring flaw. It's a clear text protocol, and that's just a fancy way of saying everything is sent out in the open, just like writing on that postcard for the whole world to see.
And this image right here shows you just how simple, and frankly, how scary it was. Your browser essentially just shouts out, "Hey server, give me this web page." And the server shouts right back, "Sure, here you go." The entire conversation just happens out in the open for anyone to overhear.
And here's the kicker. It's not a direct private line between you and the server. No way. Your data, your digital postcard, is getting passed along through a whole chain of different computers and routers to get to its destination. And without any protection, any one of those points along the way could be a listening post.
Okay, so we've established that sending data out in the open is risky. But how risky are we talking? What could actually go wrong? Well, the consequences are very real, and they basically come in a couple of different flavors.
The threats kind of split into two main camps. First, you've got your passive attacks. That's just eavesdropping. Someone's listening in on your conversation, maybe grabbing your passwords or reading your messages. But then things get way more sinister with active attacks. This is where someone doesn't just listen, they jump into the middle of the conversation and start changing things, or even pretend to be you or the website you're trying to reach.
And this chart breaks down the 3 pillars of security that are totally at risk here. You lose confidentiality, poof, your secrets are out. You lose integrity, meaning the data could be changed. Maybe a file you're downloading gets swapped with a virus. And then there's authentication. How do you really know you're talking to your bank's website and not some scammer's perfect copy?
Okay, clearly this digital postcard system just wasn't going to cut it. The internet needed an envelope. It needed a way to wrap up all that communication in a nice, secure layer. And the solution came from Netscape, the folks behind one of the very first big web browsers. They created something called SSL, or Secure Sockets Layer. Now, that technology has since grown up into what we call TLS, but the core idea is exactly the same. Create a secure, private tunnel for our information to travel through the internet.
This slide shows the aha moment perfectly. Look on the left, that's the original free-for-all. But on the right, you see the genius of SSL. They just slotted this new security layer right there in the middle, acting like a bouncer for every piece of data passing through.
You know, the really brilliant part is that they didn't have to tear down the internet and start over. Nope, they designed this as an elegant wrapper. It just takes the insecure data from your browser, encrypts it, and then hands it off to the normal internet protocols. It's security as an add-on service. So smart.
So how does this secure layer actually get set up? How do two computers that have never met before instantly decide to trust each other? Well, it all starts with a very fast 4-part negotiation called the SSL Handshake.
Now, this diagram might look a little complicated, but don't worry about the details. Just think of it as a 4-step dance. The most important thing is that this entire dance happens before a single piece of your actual data, like your password or a credit card, is sent. It's all about establishing trust first. It all kicks off with phase 1, the introduction. Your browser says hello to the server and sends a list, like, "Hey, here are all the powerful encryption methods I know how to use." The server looks at that list, compares it with its own, and says, "Great to meet you. Of all the ones you know, this is the strongest one we both support. Let's use that." Next up is phase 2, and this is all about trust. It's the show me your ID moment. The server presents its digital certificate. Think of this as a website's official passport. It's issued by a trusted authority, and it proves that the server is exactly who it claims to be, not some imposter.
In phase 3, your browser checks that passport to make sure it's legit. Once it's happy,
the real magic happens. The certificate has something called a public key. You can think of it as an open padlock that anyone can use, but only the server has the key to open it. Your browser creates a new one-time use secret key, locks it with that padlock, and sends it over. Now, your browser and the server are the only two in the world who share that secret key.
And finally, Phase 4 just wraps everything up. Both sides send one last, finished message, encrypted with their brand new secret key, just to confirm everything's working perfectly. And that's it. The secret handshake is done, the secure channel is officially open for business. And get this, all of that, all 4 of those steps, happens in the blink of an eye, completely behind the scenes. So after all that complex digital dancing, what do we, the users, actually get out of it?
The result is that single letter S. Our open postcard, HTTP, gets wrapped in that secure layer and becomes HTTPS. That S stands for secure. And that is what triggers that little padlock icon to show up in your browser. It's the sign that the secret handshake was a success.
And this secure foundation allowed us to start doing all kinds of important stuff online, like shopping. It paved the way for specialized systems like SET, which stands for Secure Electronic Transaction. It was designed to solve that huge problem of how to make credit card payments safe on the web.
Now, the way SET works is just so cool. Don't worry about the complex diagram. The core idea is what's fascinating. It uses something called a dual signature. When you buy something, it splits your info in two. The merchant gets your order details, but the bank gets your payment info. And the truly brilliant part? The merchant never sees your credit card number, and the bank never knows what you actually bought. It's the ultimate combination of privacy and integrity.
So this secret handshake, this elegant little dance of keys and certificates, is the invisible engine that powers trust on the modern web. It secures our banking, our shopping, pretty much everything. But, the threats are always evolving. So it really makes you wonder, as we move into an even more connected future, what will the next secret handshake need to look like to keep us safe?